to this. Cool. So I am recording, but I wanted to point you guys to a couple beautiful things that I've posted for you. Where is my share screen? Share my screen. Cool. I have posted for all y'all. Let's go to Blackboard. I have posted for you for all y'all to go the southern version of that. Get that up to here in your class. You guys have under course documents, under lectures. This is where I'm posting all of the lectures, as you can see. Under the neuroscience and behavior thing, I have put a bunch of YouTube videos. Again, I'm not pushing specifically to say memorize any of this crap. However, it's going to connect a lot to the things that we're talking about. This is more there for anybody that really wants to dive in a lot more. Again, I'm open for any discussion that you want to have personally, via text, via call, anything like that. If this is something that massively trips your trigger, please reach out and we can talk more about just the tiny little nuances about this. The more you care, the more I'll get excited too. Ramsey, what do you got for questions?
This is like off topic, but didn't you say there was going to be a quiz posted last week?
I'm not hearing you, man.
Oh, hello? Can you hear me now?
Hello?
Hello?
Ramsey, I can't hear you, man.
Hello? Hello?
I can hear him.
Oh, okay, that
Was
makes.
the problem resolved?
I can hear him speak.
Oh, there we go. I'm sorry. I didn't have
Oh,
the volume up. What?
okay.
I am one of
I
those
was wondering because I
people.
saw the green box and I was like, yeah, what's wrong? I was about
No,
to
no,
leave
no.
and we're
I,
just
I blame the Amish.
okay.
Anytime there's a technology issue, blame the Amish.
All right, I got it. So, Professor, wasn't there supposed to be a quiz posted last weekend?
Yeah, but some idiot didn't post it. I will post it. Actually, I'm not certain how to actually transport it from the other class. It's 5 questions. It's nothing that you guys won't be able to do.
Okay.
I'll even show it to you just so you guys can kind of see it from another class.
All right, thank
Um,
you. I was like watching, waiting for it to be uploaded, and I thought maybe you said next week, so I got a little thrown off.
no, no, you're good. This is from the other class, and again, I have no problem showing any of this too. Just because I don't want things to be punitive in any way. So these are questions like, what's the feature of a good scientific theory? Stuff like this. So those 5 questions, that's the type of stuff you're gonna see. So that's all it is. Nothing hard, multiple attempts. If you don't get an A on this, I respectfully will say you are not trying. Does that make sense?
Professor,
What do you got?
will you still post these questions? 'Cause I wanted because I
Yeah.
didn't get to read over all of them, but yeah.
Yes. I'm letting you guys know this is what I will be posting, but I just haven't put it in your guys' folder yet. Um, family sickness and stuff, that's been the freaking nightmare.
Okay, gotcha. Thank you.
Not a problem. Yeah, I'm doing everything I possibly can. I want to leave. Yes. Okay, cool.
Professor,
What do you got, man?
um, will they all be that short? Every quiz, every week, week's quiz, or
Yeah,
do they all vary in size?
they're going to be basically that length. The exams are going to be about 60 questions, basically those type
Uh-huh.
of things. this is not a hard class. I'm not trying to push anybody in a negative place. I want you to
Uh-huh.
succeed. Um, this is just a cool class.
Yeah.
I mean, if anybody really wants it to be hard, I guess I could be that type of guy.
Nah, thank you so much.
Yeah, no,
Appreciate it.
the assignments basically are just going to be some like simple reading or preparing for discussions. Your paper is the only thing I'm really asking as the major deliverable, just because I want to have something that's more personal. I'm hoping that my plan is part of next week's one is I'm also going to show you how to do part of that with some chat GPT. So how to use that kind of ethically to help start your process, get it to where it's a little bit easier.
Uh, okay.
So yeah, I got you
All
guys.
right. Thank you. Thank
So
you.
yeah, I mean, am I being at least roughly clear about everything that we're needing? Hopefully, yes. Cool. Yeah, the reason why it matters so much to me that I'm being clear about all those things is there's a concept called informational justice. And if I share good pieces of information, which is really important in a remote environment, then it increases your distributive justice perspective, which is what is associated with how you feel you earn your grade, as well as your procedural justice about how well this class has been presented. So how you assimilate the information and your happiness about the course actually directly correlates to how much information I give you. And haven't you had those terrible professors that they give you nothing, and at the end of the semester, like, oh, I was supposed to do do those 5 assignments that nobody said anything about, but they were on the syllabus, but they were in like footnotes. Yeah, sometimes people are just so heady they forget the fact that humans are involved in the process. Cool. I'm gonna get out of that screen for a second. See if it. Okay, that's not what I want. I want that. I'll start jumping onto this. Okay, I will also post these slides for you guys. Actually, I'll do that right now in case anybody wants to read. Course documents, lectures, and I'm gonna build content, file, uh, neuro, and browse files, do, 3, submit. Cool, and that should be pretty quick. And of course it's not. Cool. There you go. If you guys are wanting it under the neuro, I will move that into there, but there's the lecture. Cool. And again, all of these things are just here for additional information about what we're talking about. Totally worth watching. I also wanted to point to that these 2 files, specifically about these different types of neurons and such, more so just are really great visuals. I just want to give you visuals. That's it. The rest of this stuff is about action potential and some of the other aspects of neurochemistry. But to the lecture. Sure, 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 sure. Okay, and I want to get my chat up. Beautiful. Okay. Cool. So we're going to start about talking about some neurons, about the electrochemical actions, how the brain is organized, some of the structures of the brain. So we're going to talk about like literally the pons, the cerebellum, the corpus callosum, things like that. Some genes, epigenetics, and the environment, as well as how we actually go about looking at the brain. We don't just cut people's heads open anymore like we had to. So the first thing we're looking at is neurons. Here is a glial cell that's been stained, and basically what we're seeing is just this is what it looks like inside the brain. Very, very, very small, and these are glial cells. There's some dendrites off of that too. We're going to go through that anatomy in a couple minutes, but the neurons help us process thoughts, feelings, and behaviors. Any action that is happening inside the body, in some way, it connects with the neurons. We have neurons outside of the brain. We have them all throughout the body, and they are by far one of the coolest cells in the body. And I'll explain more why, but again, neurons are amazing what they do. So parts of the neuron, I've got some visuals for you in a second. We have the cell body. So just like any other cell, we have basically the general cell of it. We have these things called dendrites, which connect and they connect to other cells. They receive and they send out information. We have the synapses, which is the region between those dendrites. And then, sorry, the dendrites receive, the axon transmits. Um, Again, let's get you a visual of that. So this is what the cell looks like. I'm going to get that little laser pointer thingamajobby. Laser pointer. Cool. So we have the cell body here. So just like any cell, we have inside a nucleus, things like that, a normal things that you would expect with a cell. We have these dendrites that are off of this. They look a lot like trees, and that's one of the reasons why we have the term dendrites. They reach out. You'll notice that from another cell that's coming in, we have these, they look like they're connecting here. However, when we get really close inside, none of our or neurons actually physically connect with each other. That's one of the most fascinating things about this. Any information that we're getting from any part of our body. So if we reach out and we touch something that's hot, it connects to the brain and then it connects back and says, move your hand. That entire sequence that's coming up from your fingers, up through your arm, through all the nerves of that, up to your brachial plexus, up through to your head, then back through all of those areas of nerves. Not a single one of those things are physically connected. Isn't that amazing? Isn't that surprising, actually? Yeah, so I'm amazed by that. Now we're going to go a little bit more about this, but we use neurotransmitters to connect between the two. And we have these little the neuro impulses go through here too. We've got a myelin sheath around little bits of the cell. I'll connect with that a little bit more in a bit, but this is the general bit of how that kind of works. The next one. So we have three different types of neurons. We have sensory neurons, which help us get information like sight, um, light, touch, taste, things like that too. So we sense those. We then have things like motor neurons, which a lot of those are more in the spine and such that help us produce movement. And then there's the interneurons that connect motor and sensory neurons. I should turn off. Um, Whatever you'd like, man. Sorry, that was the question that was just being asked to me on the other side. So we have oh yes, please. Oh yes. That's that yes, absolutely. I'll make you a co-host. Thank you so much, Ahmed. I was thinking, what the heck are you asking about? Um, yes, Ahmed. Ahmed, you are my friend. Okay. You are now a co-host. So we have three different types of cells. We have the ones that have all of these extra little connections. This is inside the brain. The most common type that we have, as well as we have the hippocampal brain, pyramid cells, which tend to be a little bit longer with those, and the bipolar neurons that connect with that too. To see what those look like more physically, that's why I have those in here, so you can see kind of what they look like. I'll give you a quick look on some of those as well too. Um, and I don't need the sound, but that's what they kind of look like inside the brain. So they just kind of spider web out. So that's kind of the image of what we're expecting to see inside the brain. We got another two. This is what the pyramid ones look like as well too. Back to that. So the electrochemical actions of the brain. Again, it's electrochemical because we use electricity in every single thing that we do with actions inside the body. And it is an action potential. We're using physics principles on this because it literally can be measured physically. We can use millivolts to actually say how much a thought, an action, or anything can connect. So we conduct the energy and then we transmit the energy. Now, with that said, I just said something kind of profound. Our thoughts have a chemical action inside them. So right now you're hearing me and you're thinking, man, I wish this guy would shut up. That thought inside your brain had an electric signal. It can be measured. One of the first laws of thermodynamics is energy cannot be lost, gained, it can only change form. What happens to that electricity after we've had that thought? Thoughts? Do you guys have any idea about that? We can take action, but let's say we don't take action. We just have this thought of, man, I wish this guy would shut up. Most of the time we're just going to sit through and we're going to choose not to do an action, which is an action unto itself. But what happens to that? Emotions can arise. Right. So we actually can have an effect of an emotion. Well, an emotion has another chemical reaction that's occurring with that as well too, which is an electrical impulse. So that's one of the reasons why in the past we tried things like electroshock therapy, because we learned that it was a possibility of something to treat. We have actually started reusing some of those for advanced cases of schizophrenia, as well as there's ways that we have been able to start treating some of those things with depression now. So we are using electricity again as part of the brain. Yeah, sometimes, especially when we were just using that hardcore, it was making things a lot worse. I can say this from a very personal perspective. My grandmother was schizophrenic, and she was treated with electric stimulation very frequently because she was a much, much older woman. So during the time that she was being treated when younger, she had a lot of those treatments. Man, until she died, she had some major, major psychological issues that were not just schizophrenic. It was because of those treatments. So we're using them a lot with caution, and we're also using a lot better science now to start saying how effective they can be for certain areas. It's not the first place people jump to, but it's something that is a possibility in treatment nowadays. But the argument I'm kind of making to kind of come back to that point of energy cannot be lost or gained inside of thought per se. The massage therapy world, the physical medicine world argues that our tissues hold our issues. Have you ever seen somebody that says, I'm not stressed, and they've got their shoulders as earrings? Well, think about it. We're using a lot of energy to hold our shoulders up like this. And since it's kind of even stuck here in some cases, it presents a lot in our physical muscles and things like that too. It shows a little bit more of a connection of the brain-body connection, a little bit more of an argument against, not saying it's completely against, but it's an argument against that mentality that we have a dualistic perspective of brain and body being separate. Just a thought. Yeah, it can manifest outwardly. And I mean, you've seen that sometimes. People that just get so stressed they get sick. So just throwing that out. Okay to move on? Cool. We have in the neurons, they it's a passageway to collect that, connect the electrical charges. We have something called a resting potential, which shows the difference between the electrical charge inside and outside of that cell. Then, when we actually get to a certain point of where it's changing the polarity, so either positive or negative, when it changes to the other type, it then sends that signal. It's an all or nothing thing once they get it, so it's an on and off, so it's binary. And based off of that, it then will respond, and then it goes into a refractory period, which says that nothing can really happen during that very, very, very minusculely small amount of time. Um, yes, I think that, yeah. So one of the ways that we started initially studying this is we started studying this in squids. Squids have no spines, and they were able to look at the axon and the nerves inside of these squid cells running electric current through them, and they were able to physically see the process of connecting that. We have been looking at these things way back into the late 30s. So we've been looking at these for a long time. Now, I will say too, my grandmother, for example, when they started doing the electric shock stuff, it was right after the 1930s. It was into the 50s and 60s that she was getting those type of treatments. And that was right at that point where it was new. They were just thinking, well, great, we've got this treatment, we got this idea that can affect these people's brains. Well, here's the question. Should we have jumped immediately there? Argumentally, I mean, from history, no, we shouldn't have. But we know a lot more now to make it more effective. To go into the perspective of what actually the action potential and the resting potential happens with all of these things, you'll see a sine wave here. This is basically to make the sound of this, it's a boop. When you're hearing that, we've got the loud and then the rest of what's happening there. That is happening electrically between each one of the cells. When you look inside, you'll see Na and C. Guys, remember from chemistry what Na means? Okay, and what's K? Potassium. So potassium and salt are really, really important to connect any of our thoughts, actions, and this is not just thought, this is any action inside the body, making our heartbeat, breathing, all of those things are connected through these types of nerve actions that are happening. So when you get sick, what do you need? What's the thing? What's Pedialyte? What's the big thing inside a Pedialyte or Gatorade? Electrolytes, right? Electrolytes are potassium, sodium, other trace minerals like that, which are part of these processes. So having a really low salt, low potassium diet can cause massive problems inside the body. We actually need salt. We need to have potassium, or else big bad things happen. Potassium is actually a little bit more important inside heart function to be able to get the nerves to connect with the brain and the heart to say, hey, beat at this certain rhythm. Does that make sense? Now, part of this whole thing that's so fascinating is it's connecting with when it's sending a sodium protocol or a calcium, not calcium, I'm reading K as calcium, potassium, when that's sending through, it sends a the speed of that particle, the 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 neuron can tell the difference between a beep beep or a beep 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 beep. All of those are binary little movements. The amount of particles that go through will give the amount of information that's occurring. We have a binary connection between the chemicals that are being connected between our neurons. Make sense? So we are machines in a lot of ways like that. Have you guys ever heard that type of thing before? Well, I don't want to labor on the points of all this too, but it's really fascinating. This happens with everything in our body, or else literally we're dead. We a body that does not have these type of actions in different areas is dead. What about people with HBV? Could you say what HBP means,
Oh yeah, like high blood pressure when they recommend you have a very low sodium diet.
right? So one of the reasons why they're saying a lower sodium diet, not a no sodium diet, because if we had no sodium, that would be detrimental to the body. There's going to be salt in every single thing that we eat. There's actually a little bit of salt in a lot of our water too. That's why it's a bad thing just to drink distilled water. One of the reasons why we want to have some type of salt is to connect with it. But people that have high blood pressure is that they're getting too much of that sodium coming through, and thus it's sending too much signal in cases like that, which makes it to where it'll pump the heart faster or make other parts of the body work faster in ways that it shouldn't. So we're trying to change the chemistry that's associated with this. Having a high blood pressure can really affect psychological states. Can you guys give some examples of somebody that you know has high blood pressure? What are we expecting likely to see emotionally from somebody that has high blood pressure? Irritability, rage, anger. One of the reasons why, and I'll connect with this a little bit too. So we have our heart. Our heart, um, we have blood vessels that come up our aorta. It comes inside of our brain into a section called the circle of Willis that's in the center of our brain. It's this really cool little spot, and I wish I brought one of my spines that shows this, but inside the circle of Willis, that connects and sends all throughout the brain all over. From the circle of Willis, it connects to the side of our head. This is where we have a whole bunch of nerve and blood vessels. When we're oxygenating blood into these areas, that we'll go into that a little bit too in a few minutes. For it affects these parts of the brains. We'll get into that, and you guys can connect with it as well too. But it connects to that side of the brain, side of it. So it will actually connect. Let's move to the next point too. So yeah, we're creating a domino effect with all of these things. So one thing happens, it connects to the next one, it connects to the next one, it connects to the next one. And again, we use sodium ions to connect with these things, or potassium ions. Those are the main ones that are used. We have the axon, that is a space between the myelin sheaths. Myelin is made mostly of fat and cholesterol. So there's a very big argument nowadays that low cholesterol diets are actually terrible for the brain. That we're arguing that we need to stop doing things like margarine in our diet. We should be actually using butter because it is making it to where we are having demyelinization, and thus we're not getting great connections between these nodes of Renvier or Renvier, if you want to call it through that too. The demyelinization is very, very common in things like muscular multiple sclerosis or Alzheimer's. Some of the things that we're starting to see a lot more of. So, but that's where we start seeing the demyelinization, the weakening of that to the point where it's almost even gone. We have knob-like structures that are at the end of those things. So that's where we have the little knob, another knob like this, and they connect and sending those little neurons between, not neurons, they're sending the little uh, neurochemicals between the two of those. One's the transmitter sends between the two, one receives, and then there's the one that sends, the one that receives. The presynaptic one sends, the receiver receives. Clear? I'm guessing as much. Cool. And there, those are a little knob-like thing. The synapses connects similar to that, and we send those things through. And then we just have bunches of those just built off of each other. So, some questions to consider. If given a neuron makes 1,000 synapses connections with other neurons and tells dendrites which sorry, I'm not seeing the whole thing. What tells the dendrites which neurotransmitters to flood? Got any questions or thoughts of why? Which ones, how does it say send potassium or send sodium? Right? Receptors will only accept those that fit. But how do we know which ones to send? How does our body innately know which ones to send? But the receptors are the ones receiving. They don't choose what they receive. How does the synapses do it? It could be in our DNA, yes. And it's in our DNA, that's where it's encoded. I'll make it a little bit easier. The reason why is based off of the speed by which that we're getting that beep 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 type of response. Again, I'm making an auditory representation of the of the of the electrical impulse it's getting. So the speed by which it's being sent, it says which one of those to send through. So yeah. Now, what happens when the neurotransmitter has left the synapses and it's been relayed? What happens if there's not a receptor to receive it? Me, my throat hurts. I love it. Stuff like this. This isn't, it's an enzyme reaction, but we start getting things like diffusion. It'll just go out into the area around there. Now, what's interesting about that is if we have circumstances where, yeah, it gets reabsorbed. That's the term for that is reabsorption. Think about this also too when it comes into that high blood pressure circumstance. If we have more sodium, and sodium is the one that's easiest to talk about with this. If we have more sodium that is going and being diffused out, then we start getting things like swelling, edema. So that's why we want to have just the right amount of sodium. And that's part of something that is way beyond the scope of this class to be able to talk about, well, how do you get that for the right diet and things like that too. But a person's diet has an awful lot to do with psychology. We are what we eat. Let's get back to that. Cool. So we have different neurotransmitters. So these are different things that are inside. So we've sent those electrolytes between the different nerves inside the nerve cell. We have a whole bunch of different neurochemicals that are involved with this too, and these also are sent as well. We have neurotransmitters like acetylcholine, dopamine, glutamine, GABA, norepinephrine, serotonin, endorphins. All of those things can dramatically affect how we respond to different things. So if we dump a whole bunch of dopamine on our brain, it's the best way of describing it on our nerves. What happens to the body when we get a whole bunch of dopamine? You're doom scrolling. What do you get? You can get burnt out. Right. That's one thing. But you can also, for a short term, it feels pretty darn good because you're getting a reward from your brain for, oh, I like this. Oh, this is engaging me. Of course, too much of that state of arousal can be a very bad thing. So we want to make it to where there's a good balance between these. If these are dramatically out of place, we can have some very, very, very bad results. An example of serotonin, if that is massively out of balance, there's a thing called serotonin syndrome that basically just almost completely shuts the brain down. So you can go and look that up on your own, but serotonin syndrome is a very horrible experience to happen. Can it cause addiction for men? Yes, absolutely. And that's part of the thing too. Our brain starts to actually crave certain types of neurochemicals because we have trained our nerves to require certain things. That's why when we use certain types of drugs, we can say, so you've been trained to need this, or your body is saying that it specifically needs to have more of a certain type of neurotransmitter, or it doesn't produce a certain type of neurotransmitter. We can interrupt that by saying, okay, we've taken this medication. It's saying that we need to have an increased action of that neurotransmitter, meaning we need to have more of it, or we can say, we don't want to have so much serotonin. So things like serotonin rehab uptake inhibitors, that would be an antagonist. We have the agonists as well too that work with that too. Have you guys heard about that? Somebody just asked, does this happen with too high of a dose of an antidepressant? Yes, absolutely. That's exactly what I'm talking about. So has anybody heard that about different types of neurotransmitter drugs? Cool. So a SSRI is a serotonin reuptake inhibitor. It's one of those things too that would block that. It's an antagonist. So those are the different types of drugs. It directly can affect this. Now you have to remember too, that's inside the brain, but it's also going to affect the rest of the body too. So if you have drugs that are causing side effects like restless legs or sexual side effects and things like that too, like either an inability to hold an erection, get a have an orgasm, or possibilities of problems peeing, those are sexual side effects, and they can come from taking these types of drugs as well. So it's not just that they affect one small part of your brain, it affects your entire body. So sometimes when, as psychologists, we ask strange questions like, so tell me about your pee. How often do you pee? Are you having any problems getting an erection? Now that doesn't sound like it sounds like I'm asking very personal questions. I'm trying to find out, are we having a problem with your medication? And something like that also means, do we have to have a coordination of care with your primary or the psychiatrist that has actually prescribed those medications? In psychology, we deal a lot with this stuff. So getting to know the different medications associated with this are really, really, really smart. And starting to just to see the first question, does this stop the neurotransmitter response or does it add to it? If for some reason you're finding that a drug is ineffective, maybe you're on the wrong one, and the doctor is going to try an antagonist versus an agonist. So that's one of the reasons why they try different ones. Does that make a little bit more sense too, why some drugs don't work for some people? Yeah, some meds that I've been on just do absolutely nothing for me. Some some are fantastic. I mean, Lexapro is something that has worked exceptionally well. Prozac has done crap for me, just personally. Um, have you guys experienced that type of stuff or had family members experience those type of things? And anybody wanting to share? Like a time where the medications didn't work and then you tried something else and it did?
Well, can I just say something?
Sure.
Um, I have noticed there's not like enough research out to treat PMDD because
Mm-hmm.
there just hasn't been enough. I guess there wasn't enough like tests done on women. I guess it was geared more towards men. So a lot of psychiatrists struggle to treat that or they struggle to acknowledge it because they fear the risk of that, what you were talking about earlier, serotonin syndrome. So that's why there's like not exactly a treatment plan as far as like pharmaceuticals go for that
And
condition.
could you define your term PMDD?
Premenstrual dysmorphia disorder.
Cool. And I know that, but it just we want to try to define our terms first just because not everybody's heard these things. Um, and I really one of the reasons why I do a lot of gender research is I thoroughly hate the way that women are treated by our medical professionals. It is the worst incivility in the world. But most doctors were male at the start of this, and we're still kind of getting out of those worlds. Um, yeah, that is a new world we're kind of getting into, and a lot of times people just throw an antidepressant and think it's going to solve everything. Well, no, we're dealing with more than just the brain being the issue. We're also dealing with the the hormones that are associated with reproduction. So there's an awful lot more going there. And did I go too far with that? Cool. Stephanie, I just anytime that I always am talking about something gendered like that, I want to make certain I'm not just putting a foot in my mouth about that too. Mansplaining is a thing, man. Cool. So yeah, here's what the agonist and antagonist kind of look like. So if we have a circumstance like this, we have an agonist, which is going to increase the action. We start having on the receptor sites, we have drugs that start binding a little bit better. They use nicotine as an example here too. So something like this where, Wellbutrin would be a good example of this. Wellbutrin actually has been very, very useful for helping people quit smoking. And the reason being is that it binds the need for nicotinic acid, which, by the way, is produced inside our brain. That's why smoking is so freaking addictive. Our brain naturally produces it. Well, we start needing more and more and more of it when we start saying um, that our body um, has an organist like that, it will receive the that nicotinic acid more, and we crave smoking less because our body's getting what it needs. So yeah, and then with Prozac, it's a reuptake inhibitor. That's another one too that kind of works with that as well. We then have the opposite, where we have the antagonists, which are blocking stuff like that too. So naltaxone, I'm always bad at pronouncing that too. It blocks some of those too. So it already says, hey, we've already got enough of this. Just diffuse that on the body, have it just pee it out. Eventually, it'll get picked up by the limbic system, that limbic system, the lymphatic system, and it just pushes that crap out. So, is that pretty clear? Cool. I'm sorry, I'm getting so excited about stuff like this. This is one of my favorite things to talk about. I love neurochemistry. Hopefully it's showing. So then now we've talked about the inside of cells. Let's talk about the larger part of cells. So we now have a cell. Cells make up organs. Organs make up systems. So before we start looking at the organ like the brain, or the different organs inside the body, let's go a little bit further into the systems. So we have two parts of our nervous system. We have the central nervous system and the peripheral nervous system. Central is basically our brain, spinal cord, and it supports perception, how we are aware of our surroundings, motor functions like how we move, um, how we um, how we ambulate, how we grab things, things like that. Also our emotions and our cognition. Now, again, notice that's a part of the brain and the spinal cord. The spinal cord actually does connect to part of the brain. We do feel emotions in parts of our body. Just like I was saying that we have shoulders as earrings, that's an example of that. Or you heard the phrase, we've had a gut feeling in the past? Heard that before? Cool. We have something, and this is not something that we're going to cover, called our enteric nervous system. It's in the lining of our intestines, and we actually have the majority of all nerves in the body are actually in our intestines. Now, they're saying in general that the research is showing so far that it has nothing to do with emotion, but I'm sorry, I'm going to use just the pop science mentality of it for a moment and say, you got that many nerves? We've got phrases like that connect about our gut feeling. I I think that there's some aspect of connection that we just have not found research on. Not backing it up with anything, but there we go. We also have the peripheral nervous system that is not just the spine. So we have on the right here too, this is the central nervous system. The peripheral nervous system is all these different nerve clusters and things that connect off of that. We have the autonomic and the somatic nervous system, as well as the sympathetic and parasympathetic off of that as well too. So we have voluntary movements, and then we also have involuntary things like your heart beating, your breathing, things like that too. Yeah, Alana, you made a good point of saying, yeah, they're investigating the gut bacteria health and brain health. It's a big thing in the natural medicine world that we are starting to look a lot more into gut health, about how that connects to everything else in the body. No matter what, how we process food happens inside the intestines. So what we eat becomes what it connects to the rest of our body. So there is a connection. We just can't say it's an emotional connection directly. I basically just covered this too, but yeah, it carries involuntary things through our blood vessels, our body organs, our glands, things like that too. Our peripheral nervous system is pretty dang amazing as well too, because it happens a lot of times when, well, we're not a lot of times, almost all the time. We don't have to think, breathe, 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 or heartbeat, 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 or else we would die if we tried to have any other thought. Some things are just happening. Um, there are there's a room specifically, I think it's in Colorado, I'm not certain exactly where you go into this room that they have almost total sensory um stimulation taken away. There's no sound that you can hear. And they made an argument saying if you can stay in that room for I believe it's a total of 1 hour, that they will give you $1 million if you can do it. There has been no one that's been able to do it because you start actually hearing your own pulse. You start hearing your own breath. And those are things that we're not used to hearing because we're getting other sensory information coming in. It drives us nuts to just hear those things of our peripheral nervous system actually activating. So it's kind of turning off. Now, there's things about our peripheral nervous system that, for conditions in the neurodiverse perspective, that that make it to where we get too much stimulation and we start taking in um, we start actually starting to hear things like our intestines processing food. We start hearing our breath. Those can cause it to where we just can't communicate because all of that stuff is going on. So, and maybe it's not an hour that they had to spend. Maybe it was like um a day spending in there. But yeah, it's something that people just they lose complete another time in there because unless you want to start counting heartbeats, maybe that might be it. But they found nobody zen enough um to be able to truly do it. Although I would love to see the Dalai Lama or somebody try something like that. It would be absolutely fascinating. So yeah, it's worth looking that up because it, if you want to try something really truly amazing, that might be worth your bucket list of trying to go look it up. Yeah, it's a complete sensory deprivation room where they've basically turned off almost all sensory information that you can come in with. Yeah, it's more than just a white room. They there's also two a complete white room with smooth walls would actually bounce back sound incredibly well. So it has a whole bunch of really jagged edges that block bouncing of the sound back to your ears. So yeah. So we have a whole bunch of other things in there too. So like being able to dilate your pupils, relax your brachii, constrict your brachii, move your heartbeat up, down. I mean, as you can see, a whole bunch of those things as well too. Um, they have here too, and this is another one of those examples of a purely male example of this. It stimulates an ejaculation or physical arousal of the penis. They easily could have just said sex organs with that as well too, because orgasm could have just been the argument on that too, or an engorgement of the clitoris would be another example of that as well. But of course, they decided to make this phallocentric and male-based. I freaking hate medicine. So, and again, I'm not trying to be gross. I'm talking about the biology of these things. Sometimes we talk about very awkward things biologically about stuff like this, but it's important. I mean, without talking about sexual elements, we physically wouldn't be here. And also in psychology, sexual elements are a very big part of our biological imperative. So highly important. In the central nervous system, we have spinal reflexes. Those are connect to slow twitch muscles. So like our posture, things like that, being able to stand up, the contraction of the muscles to be able to just balance with our core and things like that too. But then we also have fast twitch muscle reactions, which are things like being able to move your arm, move your legs, things like that too, which are kind of more important from a biological perspective of hot, move my hand away. Which there we go, hot, move away. We have a sensory neuron that senses hot. It goes through all the way up the arm, connects to the spinal cord, to the brain, or at least to the direction around there too, depending on where it is. It then sends back through the motor neuron and says, "Oh, activate the muscle and move the hand back." So kind of cool, right? Now, how fast is that? Think about this is electricity. Is it faster than light? Well, I would argue it's not faster than light. Electricity moves pretty close to the speed of light. But remember, we have connections between each one of these things as well too, that we're sending sending those electrolytes, the neurotransmitters between them. So there's a little bit of a slowing between each one of those. Again, not to the point where we wouldn't be able to, I mean, it'd slow down to a slow motion situation. But we would not be able to, our brain would not be able to visually see this light come on and see the light before we felt that. We would see the light, but there wouldn't be enough time between the two to see and connect them. So again, another your amazing body. We have parts of the spinal cord. My wife lives in this realm as a chiropractor. Um, we have 7 cervical vertebrae, 12 thoracic vertebrae, 5 lumbar, and then the sacrum technically can be broken into 5 different regions, but more often than not, we refer to as one type of section. Now, the reason why this is worth mentioning is that if we ever have damage to any of these different regions, it can cause downstream effects to the peripheral nervous system. So let's say I get in a horrible accident and I get a fracture or I get paralyzed right at about T5. What do you think would happen to the body? Anybody?
You wouldn't be able to walk.
We wouldn't be able to walk because that's part of the leg muscles. So none of these things, none of the stuff below here would work. But right at T5, now we're having problems breathing. Not to say that we're not going to keep breathing, but we're not going to be able to do things like diaphragmatic breathing. We can only do clavicular breathing at that point, which also can create a flight or fight response. So it can be kind of problematic. Now, if we had a problem where we got a fracture at C3, that diaphragm, which, yes, is down in this area of the body, would make it to where now we're having a point where somebody may need to be on a they might have to have a tracheotomy or something along those lines to be able to breathe because they can't actually truly get the movement to pump the lungs the way that it's supposed to because there's no connection between the two. So it can cause a lot of issues. I had a friend yesterday that had a surgery he had a discectomy. He had a very, very bad disc herniation here and here. So they went in and they surgically took off the part of the disc that was compressing into these areas. What type of problems do you think he was having biologically that necessitated the point of surgery based off of just what you see here? Again, damaged right here. Anybody? What symptoms would you assume he would have? He did have trouble walking. It was actually radiating down one leg to the point where he couldn't walk. But that's something that can be actually dealt with non-surgically. What was the point where why did they say surgery is imminent, we have to do it? It actually wasn't the pain. Pain's not enough of an indicator to have surgery. His spine was actually already disformed. Actually, I might be able to quickly show you guys even his MRI. Now his main thing that he was having an issue with was the fact that he was having major bowel issues. His bowel, he was at the point where he was having a problem defecating, and he was having an issue called Claudia equina, which he was feeling almost like a numbness around his anus. That is a major indication that if we do not have surgery, this will become a very permanent thing, and that is a horrible circumstance because if you can't control how your anal sphincter works from a autonomic nervous system perspective, um, you can just poop yourself without even knowing it, and that's not good. Are you guys able to see this image? I'm trying to get the angle at that just right. Hey, I'll stop this for a second just to show you that, yeah. Uh, I don't want video off. I'm gonna stop the share and see if I can get yet any closer on that. So, come on. Come on. Okay, I'll upload this image because I actually did mention to him that I would like to show this in class and he said it was completely fine. So I'll upload the image and he will just love the fact that I kept talking about him pooping himself in class. He's also a professor as well. Pooping professors, isn't that a fun alliteration that no one ever thought you'd hear me say? So there's some things that we as psychologists are actually starting to do with this, and these are psychologists doing these type of work, not actually all medical doctors and things like that too. So this fits in the realm of psychology. We have started looking at having monkeys be able to control cursors on and play Pong just by attaching electrodes and such inside their brain, and they're able to think and play Pong. Kind of cool, right? We've started moving those on since 2003, now doing that with human beings. So we're going to be at a point where if we have some people with very high levels, meaning high in the spine levels of fractures or just breaks of the spinal column, we're I believe that within my lifetime we're going to have it to where we're going to be able to um have ways around some of those type of injuries, and we're going to have people walking again and living again like that. So it's going to be some pretty amazing stuff. We've had people that have lost arms be able to control motor interfaces, so biological perspectives. But it just depends a lot on what is actually happening with the body. So next, we're going to move into the structures of the brain. Do you guys need a break? By the way, break before we start going on to that? Cool. Yeah, I'd like to drink coffee for about 5 minutes just to make my life a little bit better. But is this interesting? I know you guys aren't talking a lot. Yeah. So I hope my fervor's coming across on this too, because I deal with this on a clinical side every single day. And I'm, again, I'm not a chiropractor, but man, I talk about this every single day. Awesome. Cool. How about 10:50? Note I'm street by calling it 50. I'll see you guys at 10:50, okay? P well for those that will take it. And we're back. Okay. Are we ready to get back into the brain? Cool. My son is awake, so I'm gonna try to push through as much stuff as possible because I don't know if I'm gonna have some family work conflict and have to race to deal with that as well because of everybody's illnesses, but it's good. Cool. So, are we all back? I want to get my chat back. Cool. So we have three different sections of our brain. We have the hindbrain, the midbrain, and the forebrain. Hindbrain has stuff like the medulla, the reticular formulation, the cerebellum, and the pons. Midbrain has the tectum and the tegmentum, as well as the forebrain has the cerebral cortex and the subcortical structures. Again, a lot of words. Hopefully, oh, there we go. Here's some of the descriptions of that. Here's where the tegmentum is. Cerebral cortex is on the inside of the brain like that as well too. But basically we have the, whoops, get back here. I'm gonna get my little, whoops, come on, go back. There, that's what I'm looking for, laser pointer. We have the forebrain, the midbrain is along back in here, and the hindbrain is here too. So that's why we're calling them in three different little sections of this. And it's we'll get a little bit into some brain injuries in this as well too, because depending on where we have a brain injury, it's something that is survivable. They've actually done some studies as well too, where somebody can have an entire hemisphere of their brain removed, and not only will they survive, they'll live a very wonderful functioning life because of the plasticity of the brain. Now, there are some things like if you had one specific area like the pons was damaged or removed, you're probably not going to be able to have any motor function of the body. You won't be able to to balance or stand, things like that too. So those are the major structures of this area. We have some support structures like the thalamus and hypothalamus. Thalamus relays, filters information to the cerebral cortex, parts of the limbic system. The hypothalamus regulates our body temperature, hunger, thirst, sexual behaviors, and also in other parts of our limbic systems too. So again, these things directly can be affected. Note the behaviors perspective. This is not about the actual function of the sexual parts of our body. And sexual it just means of the sex organs of the area, but it's more about our arousal level for sexual behavior. Uh, but the thalamus lets us get impulses and we can like enjoy an apple. How does it feel? How does its smoothness? The seeing the the color of the apple, things like that, the tastiness of the sweetness. Of course, you're not going to get that with a red delicious apple, but the crunch when we get into it, all of that, you can thank your thalamus for doing that. The lymphic system is a group in our forebrain that helps with motivation, emotion, learning, and memory. So this is an area that we tend to focus a lot more on in the psychological realm. Um, but in the hypothalamus, it, again, like I mentioned, regulates body temperature, our hunger, our thirst, things like that too. This is the big area that produces nicotinic acid. Um, and if you'll notice too, when somebody smokes a cigarette, they are less hungry. So it's if you want to quickly lose weight, I'm not saying you should, but this is something you could do. If you were take up smoking, you'll probably notice that person will lose an awful lot of weight because they'll have less hunger and thus eat less. Something that kind of happens just naturally inside the brain because of that process. It's one of the reasons why, too, when you start putting something like Wellbutrin, what that does is it makes a person start gaining weight because all of a sudden they're just hungry all the time. So some people that go on Wellbutrin start just ballooning up because they start eating more. So it's something that we also, as psychologists, will often have to talk to them a lot more about saying, I know you're having increased hunger, but let's talk about concepts of self-control. The You can have a psychological impact on the hypothalamus by just giving intellectual stimulation into that. The hippocampus is really good for creating new memories and integrating them into the web of all the information we get in our long-term memory. The amygdala plays a central role in our emotion processing. It's also referred to as our lizard brain, and it's right in the back of the head. Do I have a picture of that real quick? Where that is? Yeah, amygdala is right in this area. And part of that too is since it's part of that point, reason why we call it a lizard brain is it's where we get the emotions like disgust, anger, just those innate, really quick responses we get to certain things. Some people argue that I believe it's our system one action in the dual system processing theory, will occur in that area of the brain. We then start looking at our other systems that start training, that give information to the amygdala about how we should be processing that type of information, whether or not we actually will change our level of arousal. Am I going too fast? Okay. I just want to make certain. I've got a bunch of extra little stuff about this if you want to just get in a much deeper dive. Um, the basal ganglia is also a set of subcortical structures that directly helps with movement and plays a role reward a role in our reward processing. So that concept of, oh, I deserve a cookie with this can be very, very useful. But it's not just about the fact that I deserve a cookie. We sometimes will actually have a problem with our basal ganglia over sensitizing, and we need to constantly get into this constant state of needing to have a reward, and it's diminishing on that too. So if you start taking, let's say you start taking methamphetamines, what will happen is that first time you take it, oh my gosh, what a fantastic experience you'll have. Next, second time, what a great experience you're going to have. Next, what an okay experience you'll have. And eventually you get to the point where you're doing it just to function. And that's one of the reasons why drugs like that get to be so ingratiated with brain function, not to mention all the other terrible stuff it does with the rest of our body. But the basal ganglia gets the information from our cerebral cortex and sends out um, connections to the rest of our body through the brainstem, through the stratum. Um, So some real world examples of this type of thing that has happened. So Instagram and Facebook announced at one point that they would hide the options if people didn't want to see their like counts on stuff. What do you think that did for people's rewards, the reward system in their brain, if they decided to turn those off or on? Have you ever really seen anybody with having likes on and on Facebook if you're still using Facebook? Yeah, it definitely diminishes when it turns off. You have to go out of your way inside Facebook or Instagram to turn those things off. They actually want those on because part of those social media apps is they want to connect to that addictive perspective of your brain in order to keep you engaged with it. That's one of the reasons why doom scrolling and this algorithm based marketing that they're doing to you is so incredibly addictive. They want to use the hardwiring perspective of your brain. They've done some research specifically with fMRIs on adolescents during these things as well too, which a couple of you are doing papers about this. It would be very, 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 very smart to include some of those things inside your papers, just because it's interesting. It's really, really, really interesting and it connects. Um, it's also very effective if kids are being bullied or victimized at school. That impedes their reward systems i- and their motivation. It makes it to where, in some cases, some people actually look to be victimized because their brain, and I know I'm not saying that they're trying to be a victim. Please don't realize that's what I'm saying. I'm saying that they tend to start replacing the response of saying, "Ooh, this is a positive perspective of being, I mean, a negative experience of being victimized." They start changing it into their brain about saying that they almost want to have that. It is a horrible, horrible psychological perspective, but it can happen, and it's something that, especially in child psychology, we need to be very, very cautious on. It is not my area of expertise. I cannot speak to that as well. Does anybody else here have any specific comments about that that could speak to it a heck of a lot better than I can? Does anybody want to talk about social media in this world? I am thoroughly shocked that no one is wanting to talk about social media. Wow. All good. Yeah, fatigue. Yeah, fatigue is something that would be what. Okay. Ah, very fair. Um, Jamal, when and if you want to speak on this and the stove is off at that point, feel free to interrupt whatever I'm saying to jump back to this, okay? Yeah, and yeah, TikTok is no longer banned right now, but I really, really, yeah, and that victimization aspect is something that I'm specifically mentioning. It could specifically be something that pathologically could occur. It does not mean it happens to everyone, but some people actually do get in that cycle that's with it too. But somebody had mentioned about TikTok being banned. Why do you think so many people got so up in arms about that? I mean, uh, dude, you're taking away their drugs. Yeah, we're gonna get upset about that. Free speech can be a very big argument about it, but you're taking away people's drugs at that point. So part of that too is that people are going to react to that. So yeah, I just throwing out that perspective. It it's something that is hardcore affecting our brain. It's something that influences every aspect of psychology. Social media is the bane of our existence, but also it's something that can be very, very, very helpful. But that's one of the reasons why a lot of people are suggesting some of the digital downtime. It's actually very, very necessary to purposely take yourself off of social media for a few hours a day at least to let the brain just kind of normalize because it's normal is being on social media. I mean, how many times do we check our phone during a day? Yeah, people are so sick of it, but they can't get enough of it. And the reason being is we have that reward cascade. We're in that perspective where our brain just constantly keeps needing it just to get to that point of what we think is normal. So having digital downtime is something that I personally recommend. Um, it might be really good to if you could do an hour before going to bed, not looking at social media, maybe 10 minutes before going to sleep, not to mention the red light. I mean, sorry, the blue light. It is blue light stimulation to the eyes. Um, if you can do that, you'll get better sleep. That's something that's definitely been shown in the research as well. So I won't labor the point. I will move on. The endocrine system is another system that is in the body, associates a lot with hormones, actually all about hormones. Um, Helps a lot with metabolism, growth, and our sexual maturity. So meaning that as we reach a certain point in our age, it's something about sexual reproduction. Our body starts growing. Again, it's the more you're changing body mentality. But that's something that's naturally part of our evolution. Now, there are discussions about um, I'm sorry, the word just escaped me. I don't know why I'm doing this. Um, where we're trying to stop hormone production. So a person puberty, that's the word. I don't know why my brain stopped on that. We're actually trying to stop puberty for some people with either sexual reassignment surgery or things along those lines. Some drugs actually will stop that process of testosterone production or slow the production of estrogen and progesterone. Those things do affect the brain. They do affect the all the other hormones. If you mess with one hormone in the body, it will affect every other hormone in the body as well. So we have the thyroid, the adrenals, the pancreas, the pineal gland. All of those things will affect how our body grows and how we metabolize things and how much blood we pump and things along those lines. The pituitary gland. Okay, Jamal, Bring it. What did you want to comment?
All right, it's Jamel. It's Jamel.
Jamel, I'm sorry.
It's fine. It's fine. But basically, I wanted to connect the children bully thing and TikTok with or social media in general. I feel like what is it? Students, not students, but kids when they're bullied, they like you said, they get attached to that feeling of bullying, but I feel like it's because of the stuff that happens with their bullying in specific. It's like they get isolated. So because they're isolated, they lack for that attention. They don't have the attention they want the need for it. So getting bullied, despite how toxic it is, they get the attention from that. And then those kids who are usually bullied are the ones mainly on social media, either posting or taking in posts. And well, damn. But yeah, that was the main idea. I forgot the rest, but
No, I'm gonna connect slightly with what you're saying on this, and I am going to in a major extreme. This is not every single kid. I want to make certain I'm very clear about this. This is one of those arguments also about school shootings and such, that some kids that are massively bullied, some will go to that massive extreme of taking a gun to school, and they just want to get that attention of not just about retribution, but they needed to get something in order to say, look, I have a problem, address my problem. It's not right in any way, shape, or form, but that is one of the types of arguments that's least out there. Again, major triggering topic, totally not my area, but it is something that is at least somewhat in some of the literature. Please go and do your own research into that area. Is that fair? Did I go too far?
no, that's a fair point to make.
Okay, cool. I just want to make certain that I'm not I that is a extremely polarizing statement, but I again I think we need to talk about polarizing statements sometimes to even just say, well, is there merit in that? Because this is science. Science should be questioned all the time. We always get new theories. We're moving the target. But yeah, let's get back into the pituitary gland. This is the master gland of body's hormone production. And it releases hormones, controls our stress, things along those lines. If we're having any dysfunction in the growth of the pituitary gland or the function of the pituitary gland, it affects almost every single tiny thing that happens with the body. So we can have either no stress response or almost extreme stress response, which then also affects digestive activities. So are we processing food properly? Are we processing it too well? Things along those lines. Sometimes the pituitary gland can have at points where we're getting infertility issues. Um, Very often, one of the main points that we treat for people that have fertility issues in acupuncture is the point right here on either side of the nose. It's called welcome fragrance in Chinese medicine. And it's right on either side of the nose, so you can see why they would call it welcome fragrance. When you put needles there, it opens up the sinuses, which, by the way, the sinus production and sinus opening and such, and sinus drainage and everything directly is connected with the pituitary gland. So that's one of the ones that's there. Also, another interesting side note too, that's the end of the large intestines channel. I just always think that that's interesting because no one would ever expect a welcome fragrance coming out of their large intestine, but it's more about the name of the channel, which is on the western side. The eastern side of medicine, they refer to it as welcome fragrance. They don't call it the large intestine channel. Just a worthless side from the Chinese medicine world. Yes, so our endocrine system's in multiple different places on the body. So again, we have the pituitary gland and pineal gland are actually inside the head. Thyroid is actually in our neck, right next to our vocalis muscles and our larynx. Pancreas, adrenal glands are right in the center of the body. So a lot of those things, those all connect straight up to the brain. They're all part of this as well. And at least here we're getting a female representation somewhat, but those are either producing testosterone um, or progesterone and estrogen. What is very interesting is that men do produce estrogen. We do produce we also do produce progesterone. And the same that women produce testosterone. We just produce them at different levels because the body doesn't need them as much. They're different sexual hormones. So have you guys ever heard that before? That women actually do produce testosterone, men do actually produce estrogen? Well, you actually produce it all the time. So it's not that you're producing it only during follicular or for women, follicular or the luteal phases of your menstrual cycle. It is it is happening all the time, just at different levels for each one of the ones that are occurring. For men, it's a little bit more regulated, but I would very much argue, and the literature showing as well too, men do have aspects of cycles as well. However, they're just not something that we study very well because, well, it's just something we haven't studied. We need to have more studies on it. If it's something that's interesting to you, please make a career out of it. So let's look at the cerebral cortex. We have four different lobes of the cortex. We have the frontal lobe, the parietal lobe, the temporal lobe, and the occipital lobe. Now, I had mentioned at one point about high blood pressure being right of something that the blood innervating that a lot right along into this area. We'll go into that in a few moments, but it's just while I've got a visual, it's worth mentioning. Things that also are worth mentioning, we have things called the gyri. So the bump or the kind of the meat part of the brain, as well as we have the sulci, which is the little creases, the ones that don't go very deep in there. The fissures are the ones that go a little bit deeper and they connect further. So like this would be a fissure inside the body going through inside the brain. So this is the highest level of brain. This tends to be a lot more associated with thought. We have the left and right hemisphere, and we have in the back of our brain a section called the corpus callosum. And the corpus callosum is where we will connect the two parts of the brain. Now, I love describing the corpus callosum from the perspective of when we take visual information in. So we have two eyes most of the case. We bring the information into our head. Now, what's cool is the way our eyes are bringing in, everything we're actually seeing is upside down because of the way that the eye is actually working. It comes inside of our brain, gets into the occiput region, flips it over, and then it sends it to either side of the brain to communicate with that. So the corpus callosum is a very, very big important thing to connect between the two regions. We have the second area, like I was mentioning, the occipital lobe area processes visual information, which is kind of weird because it's on the back of your head. So if you ever had a situation where you got hit in the back of the head and all of a sudden you can't see very straight, that's because your occipital lobe got a little bit damaged. The parietal lobe, again, let's go back to the parietal lobe, up here at the top of your head, senses a lot of touch. What's interesting too is while I'm mentioning this too, depending on the type of migraine you're having, the information that you give us to your practitioner about where you're feeling it in your head or your type of headache or the symptoms you're having gives us a lot of information about how to treat that migraine differently. Migraine or headache, there's a lot of different types of them. The temporal lobe is responsible for hearing and language. So I had mentioned earlier about the temporal lobe being something that for people that have high blood pressure. So it's right along into that area. Responsible for hearing and language. So if you think about it, you have a high blood pressure, people have a little bit more of an issue with hearing at that point. Also, they have problems with producing language. Well, think about the perspective of if you're not really able, you're upset because you have this high blood pressure thing going on with these as well too, but you also don't have the ways to articulate it. Wouldn't that make you more angry? Yeah, so just throwing that out. In Chinese medicine, that's associated with the gallbladder meridian, which is all along here, along the sides of your head like this. It also connects down into different parts of your body as well too. But whenever I'm having somebody that's having very foggy thinking, we will treat on the gallbladder meridian on the side of the head like this. We'll also connect that down. There's a couple spots in the feet that are really well connected with that whole region. The frontal lobe, specifically with memory, abstract thinking, planning, memory, judgment. That will get important in a few minutes, as well as the sensory somatic cortex is representative of different skin areas. So sometimes we'll do different neurological tests where we'll do like a little pinwheel and we'll run it along your body, or we'll take little tiny pins and we'll just touch them to see how close it will get in certain areas to find out, are you having issues with your somatosensory cortex? Those are right along in that section of the brain. So they're right next to each other. We have the motor cortex and the sensory cortex. So again, and I love the fact that there are different connections with it too. But motor cortex is where we're connecting, where we're actually doing the action. Somatosensory is how we're getting the information in. So you stove is hot. Sensory cortex is taking the information in. Motor cortex says, hey, move your hand, you idiot. And that's what happens. Kind of cool, right? And you're seeing all these little connections of where these things are for each one of those. If I were to do brain surgery on you and I would just poke right here on the brain, I could make you lose your vision completely. If I took that little section of your brain out in that area, you could make it to where you could never see again. Or feel your thumb if it's right close to it. Fascinating, right? Cool. The occipital nerve. The occipital nerve, let's see if I've got occipital lobe, sorry. The occipital lobe is right here. We get information in from our eyes, and it will go straight to back here. Now, there are, coming right out of this area, things called cranial nerves that will run to the eye itself. There's 3 different nerves that will specifically come to the eye. I believe it's 3. There might be 4. I'm not remembering all of them off the top of my head right now because I'm in gross brain anatomy. But yeah, we get that information and it processes specifically into this area. Does that answer your question, Alana?
I was just wondering about the occipital lobe because you mentioned poking that part of the brain, but it looked like it was like in the parietal lobe.
Oh, yeah, I was actually specifically talking about the sensosomatic cortex. So right here, these are the sections of the brain that how we're responding to like the touching a hot object. Or in the case of the eye, we see something and we respond to it. So the eye sees, hey, I've got a needle coming at my eye.
Mm-hmm.
The sensomatic, or if not a needle, yeah, a needle's coming at your eye. The motor cortex would then specifically say blink.
Oh, okay, gotcha.
Does that make a little bit of a difference?
Yeah.
So yeah, the occipital lobe is what's handling in the sight what we're seeing.
Mm-hmm.
This is about the quick response of, hey, we got a problem here, or, ooh, that's kind of cool.
Okay, I think I understand.
Yay. Thumbs up emoji. Association areas, help stitch with that too. Mirror. Yes, so I've got better videos of that than I will describe. So I'd recommend watching the videos associated with those. But yeah, I'll actually go into that too. Mirror neurons. One animal will observe another's behavior in a specific behavior. And then, based off of that too, um, they will try to mimic that type of behavior. Um, our mirror neurons will actually associate with this as well too. So there's a very well-known psychological experiment where we've had a bunch of monkeys that we throw them into a room with a ladder. At the top of the ladder, we put some bananas or some other type of fruit. One of the things that those monkeys will do is they will start climbing the ladder to go get the bananas. If I take and I start taking a water hose as they start climbing that ladder and I shoot them with the water hose, I know I'm a total monster for doing this, but follow me here. I shoot them all with the hose and they get to the point where, oh my gosh, we're afraid to go up there. Well, I start taking away monkeys from this. So let's say I take away um, almost all the monkeys and I start gradually taking out them to the point where I have no monkeys left in that room that have actually been sprayed with water. Almost all of the monkeys in that room will actually, even though they've never experienced being able to go up that ladder and getting shot with water, they will be afraid to go up that ladder to get those bananas because of the learned behavior that's associated with that. That is because of the mirror neutrons. It is actually almost exactly in the same exact way. That is something that I would recommend actually looking up very, very specifically, and it is a great paper topic, Rebecca. Does that make sense? It follows in the same way. Yay, cool. Moving on. Brain plasticity. I love the word plasticity. The brain is plastic. Now, again, I had mentioned actually the brain is not made of plastic, although we are starting to have plastic in every single one of our organs now because of the amount of plastic we have in our drinking water. And that's becoming very problematic. But the brain plastic means, or plasticity means that it's capable of learning and adapting, accommodates to the changing environment. So I had mentioned at the situation if I removed one hemisphere of your brain for some reason, like it was damaged or something like that too, the brain is capable of actually having the entire other side of the brain take over completely for the other one. So the brain is able to adapt to almost any circumstance you give to it. With enough time, it can adapt. Now, adapting can be both positive and negative. So we can adapt to very horrible things that are occurring. So we can adapt to abusive situations and again start to believe that those are normal. So it can be very brain-based, and it's not the fact that I am victim shaming on this. It's because that sometimes we just think that that's okay. It's one of the reasons why sometimes codependency, we think that that is okay because it's hardwired in our brain because we hardwired it that way. Thoughts? I mean, that was also another pretty painfully profound statement. Did I go too far? Anybody? Was that too far? Cool. I'm taking that as a no. Moving on up. Cool. So an example of some new mapping that can occur is with phantom limb syndrome. So have you ever heard of the situation where somebody loses an arm or a leg and they still feel the pain in that area? So some of us will actually so let's say I lost an arm. I've lost my left arm. I have my right arm. Sometimes I can, to retrain my brain, put my hand in a box that where it will also show me a mirror where I'm seeing two hands. So the mirror shows that this one looks exactly like that one. I then can treat this hand, the one that is physically there, and start working on the areas where a person's physically feeling that pain to release that. I have clinically personally done this with people, and it really, really does work with them. It shocks me. So much so, I've even done situations where I've actually done massages on someone's prosthetic leg, and it has decreased their pain in that area. So the brain has a lot of connection with how it can physically see information like that, and it then will start rewiring inside. It is mind-blowing that it can do stuff like that. But it can be even more amazing. Let's say we have an amputation here on our arm. We can actually start putting sensations into these different areas with a cotton swab and start actually having feeling in where we would have like the pinky finger and stuff like that too, if someone is having phantom limb issues. So we can treat on the face with that. We do this a lot with acupuncture, but regular medical doctors and physical therapists will use cotton swabs or other things like that too in these areas. So, pretty mind-blowing. Um, yeah, it's influenced by practice. It's influenced by exercise. It's not something that we normally just do a single time, but this is another one of those spinal cord injury situations. Um, I love that we're also using influence of practice. Um, as a pianist or as any type of music thing that you're doing, practice makes perfect. We're creating pathways inside the brain to the point where we're getting into a state of flow where muscle memory takes over. Well, muscle memory is when we're getting to where the body naturally knows how it should respond and it just follows the muscles that you trained it to do. So there are also cultural influences on this as well too. So sometimes people have different biological perspectives on that too, or different types of tools that are available that are not in others. So, yep, there are some definite effects of Alzheimer's disease. This has actually also been referred to as type 3 diabetes. You guys ever heard that? We have been getting a we have been getting so many more people having Alzheimer's disease, and it's becoming more and more and more prevalent, especially with younger people that it is occurring. One of the reasons being is number one, diet. We've been having a lot of some arguments now that we're starting to see based off some of the research is since we're having lower levels of cholesterol in our food, cholesterol makes fat, the brain's made of fat, and we also use cholesterol in all of our nerves. When we start having a demyelinization, it starts making it to where brains do not function. Alzheimer's disease is when we start having a demyelinization of the brain. It tends to happen more on the side of the brains like this. I'm going to get you some visuals. We start to see it more on the temporal lobe, then it starts moving into the parietal lobe and then into the frontal lobe. That's where we tend to see it kind of starting to grow with it as well too. But we start getting it more coming into memory. We start getting it into more long-term memory. Short-term memory is not as affected as much too because that's what we have for doing it. Can we just start eating more cholesterol? I would recommend you start eating more cholesterol. Good fats like avocado, butter is actually good too. Things like that, they're starting to show a lot more of just a good diet with good cholesterol. Drugs like statins, which actually block cholesterol, are actually becoming something that we're saying are very problematic. So sometimes there's actually been a couple studies that we're starting to look at about Alzheimer's disease associated with those using a lot of statins. There's not a lot of research on that because we've not had statins around long enough and our understanding of Alzheimer's long enough to be able to make longitudinal studies to directly connect them. But we are seeing a lot more of those, and there are things that are pointing towards that. Again, I cannot directly say that. Now, worth mentioning right now, guys, we're not able to treat this stuff. And I'm not saying that if your mother or father or grandparent has Alzheimer's, we'll just have them go eat some butter. That's not going to change it, realistically. And plus, also, a lot of times we're not capable of really, it's if there are family members, we're not capable of actually following through with the regiment that would be necessary to make a change on it. We're just too close to the problem. So this is something that is good to look towards yourself and possibly others when you're treating later, when you get a lot more information on this area. But again, I just want to open your mind to the possibilities of these type of things. So getting back into brain mapping, moving away from that. Genes. So this is not what you're wearing, but now we're getting into DNA, and some of you have started mentioning about genes. So genes are hereditary transformations of strands of our DNA that we get inside of our chromosomes. Chromosomes have different strands of them. We have a certain amount of them. I believe it's 46. Am I right, or am I wrong on that? 46? Yeah, I think we're right. Yeah. Well, and sheep have the same amount. Now, the reason why I'm mentioning sheep with that, we had we've had a replication of a sheep named Dolly. Now, the reason why it's interesting that we're able to now clone a sheep, that means that we are a step closer to being able to clone humans. Now, I'm not saying we specifically would clone and we'd make another version of ourselves, but if we have a dysfunction in one area that's based off of a gene, we can then start being able to clone something, a small part of that, that is the dysfunctional part, and make it work. We're starting to get a lot more of that in genetic medicine. 20 years ago, when my wife was going through chiropractic school and going through anatomy and physiology, they had not mapped the human genome yet. They had actually had just kind of started that perspective of it. And they specifically said to her in that point, this is going to change everything. Once we actually understand what's happening inside the human genome, we're going to be able to affect almost every single thing else about turning on and off elements of our DNA. That is starting to show, and this is a huge area in neuroscience, in neurobiology, totally getting into it. Won't the part of growing into the correct age yeah, that could affect about the correct age. It's so much so that it's going to affect aging. So there's a whole area called regenerative medicine that is a lot associated with tip of my tongue, um, with stem cell production and using one's latent stem cells, which has a lot to do about making the genes act up to do what they're supposed to do. So yeah, it's very, very fun. There's a whole bunch of new things we're learning. An example of that too is we used to think that there's a part in the body called the exosomes. The exosomes we used to think were carrying the garbage out of cells. We've actually recently learned that the exosomes actually are what activate latent stem cells inside the body. We have the same amount of stem cells in our body that we had when we were babies. But kids heal faster than adults because they have more active stem cells than when we get older. If you add exosomes specifically onto the body into an area that is needing them, it starts activating those stem cells and it starts healing younger. So again, in clinical practice, we were using an off-label version of exosomes. We were injecting them into people's veins. We had a medical doctor that was on our team that was doing this. Exosomes are a medication that is used for, primarily for helping with hair reproduction, something that's what it was being used for. We were using an off-label to inject into the body, and it systemically does um, change and start healing a person internally from that. So, my wife also had those done as well too. She had a very bad disc herniation. She had it injected intravenously, and when that occurred, it number one helped heal the disc herniation, but also since it was systemic, her vision changed. She actually went down 2 glass prescription sizes, and it's something that it's very off-label. There's a lot of things that right now the FDA is really trying to cut down on people that are pushing and making claims specifically about those because there's not enough research on it. But they are actually specifically working with exosomes right now to specifically target certain regions. Endometriosis is one of the ones that they're really pushing a lot to get information on because well, we have no real good treatment for it other than going in there, opening it up, and scraping that crap out. Um, I don't think that's fair. I don't think it's right. My opinion. A lot of um, a lot of the medical providers feel that as well too. But I'll also throw a video about exosomes on there too, just because it's yeah, without saying about injecting them, it lets you at least know what is happening inside your own body. Yeah. Um, Yeah, epigenetics is something as well too. So, environment actually does affect this as well. They affect whether our genes are expressed or not. So this could be about different types of foods that we're eating or being in certain areas that we're around. Um, so if we're in an area with high levels of radiation, well, that's going to make it to where our genes will either turn on a lot more or turn off completely, and thus cause lots of problems. There's also a process called methylation that we add a methyl group to be able to process things to make DNA, to make our blood, and to make our things inside of our bone marrow. What is interesting is that there is a genetic malformation that's not talked about an awful lot where it's a recessive trait where we lack the ability to make that extra methyl group. So when we take B12 or we take folic acid, it is missing that methyl group and we don't process it completely because we'll still process it, but we don't process it ultra well. So we don't make blood as well. We don't replicate our DNA as well. I have that trait. So does my wife, and so does my son. And it's something that in order to combat that, what you do is you take methylated B12 or methylated folic acid. So instead of taking the traditional version of B12 called cyanocobalamin, you take methylcobalamin. And I think I have, come on, get out of there. I pulled up on one of these. There is that gene mutation is called the MFTR mutation, and you can get things like instead of cyanocobalamin, you would get methylcobalamin instead, and you can get them in the same exact things, same oral under your tongue or pills and things along those lines. My family takes that. How do we find out we had it? Great question. It's an oral swab and send it to a lab. Costs about $100. Most of the time, it's not considered to be covered by insurance. Um, and with it not being covered by insurance, There is a lot of research on this, but it's not something that they have connected it to massive levels of dysfunction. We've connected it to some things like different types of headaches and different types of symptoms, but it's still on that natural medicine side, and they just don't want to pay for tests like that, to be honest. So, you can get a test like that too. Most of the time, if you want to get a test like that, go see a chiropractor or an acupuncturist or somebody that actually tries to do more on the natural medicine side. I tend to see when we have patients that come in that they've tried everything, all different types of medicines. They've tried chiropractic, they've tried physical therapy, and they're still having like strange pains and symptoms. It's one of the first things that we test to say, do you have this? Then if they do, we have them just take these over the counter things. I don't even sell them in my office. I say go to a Whole Foods or someplace like that that carries those. Go pick it up. So if you're having strange symptoms, you can take that. If you don't have it, you can still take methylcobalamin. Um, you just pee out what you don't need. So something just kind of interesting. Actually, I think there might be a good visual here. Yeah, methylization. Um, I'm gonna make certain I'm keeping that up and I'll put that in for you guys as well too, because that's a pretty good video. Cool. Back to the lecture. Have you ever heard of that before? Cool. Cool. So epigenetics, we got chromosomes, we got a cell, chromatin, and it just breaks down apart into the DNA. We got some winding inside of the histones. Histone is histio is the short word for cell. Anytime you see the word histio or hist, that means it's a short Latin thing for cell. But yeah, all of those are inside the nucleus of the cell, including our nerve cells. So we do a lot of twin studies because we have some very common things about twins. And it's a great thing to be able to say at the genetic level what's different. Now we have myozygotic twins, which are on the left, that basically identical twins. They have about 100% of their genes in common, where we have the other two, which have about 50% of the same, which when they are dizygotic twins. And this environment has a lot to do with this too, but there is a biological connection with twins that is something that's very much worth studying unto itself. You'll see a lot of twin studies for that type of reason. Um, Processes early roles, yeah. Results from rat studies demonstrate hundreds of DNA methylation differences in the hippocampus of the offspring of high and low levels of the methylation such in rat mothers. So yeah, it can definitely change a lot with the genetics that are involved with this. And that's one of the reasons why we're getting a lot more into genetic medicine, because it's not like we can change our DNA. Well, now we're starting to get to the point in medicine where we are able to start changing it, which think about what that can do for mental health. If we can start changing the inside of our nerve cells about fight or flight responses and stuff like that. So again, we're still getting new into this. I would guess in 20 years, these slides are going to be dramatically different because we're going to have new information and a moved target. So yes, irritability is the measure of the viability of behavioral traits among individuals that accounted for genetic factors. So it's an abstract concept. It's a population concept. It is dependent upon the environment, but it is not fate. Just because you are genetically predisposed to have heart disease does not mean you can get heart disease. You can change the fact that it may be triggered based off of diet environment, physical activity. Just because your family has a predisposition to have mental illness does not mean you will have mental illness. So, just throwing that out too. This is something that has been a very, very big fight in mental health because a lot of people think that if we have a family that is mentally ill, we're only going to be having mentally ill people coming out of a that family. With the concept of the apple doesn't fall from the tree, well, that's not always true. It has a point to it. And I'll use my own health about that as well too. As I mentioned, my grandmother is schizophrenic. My uncle is also colorblind. I have been diagnosed with bipolar. I'm just sharing that. Medication controlled, everything along those lines as well too. It did activate for me. It did not activate for my sister. Has no signs with that whatsoever. She does have signs of depression, but has not actually gone to the point where she is presenting to where she has cyclomatic episodes. So, thoughts? Have you guys heard that type of situation before?
I've only I was watching a show it's Law and Order.
Love
And
it.
they were talking about in the courtroom they were talking about, oh, well, this person has this gene that makes them more susceptible to anger and violence, so they should be excused for their actions essentially. So
Yep.
I thought it was interesting that you mentioned the that it's not fate. I think that is very, very important to emphasize.
And I am theorizing that in that Law and Order episode, one of the first things that the opposing counsel immediately threw out saying there is absolutely no research that directly backs up that a person would have that activated.
Yeah. Yep.
Yep. So it that can't be held accountable in court of law. Now, I totally, if that were my attorney, I would hope that they would bring up the fact that that was there because that does put some doubt in the jury's mind. Just because I'm all about making certain everybody gets treated fairly on that. But at the same point too, yeah, it probably did have something to play into that. So not gonna labor, gonna keep moving too. So now we're gonna talk about brain damage, which probably have some of this that's happened with you too. So we've been talking in general just about the normal function of the brain, but what happens when we start having issues where the brain doesn't work? It doesn't work like it should. So we start getting some situations where we start having language comprehension and language production issues. We have a wonderful, wonderful tale in psychology that this did happen. It's with the guy named Phineas Gage. Has anybody ever heard of Phineas Gage? Okay, so this is probably the thing that you will take away the most because Phineas Gage was working on the railroad, and again, this really happened. This is really Phineas Gage. He was working on the railroad, and there was a bit of an explosion with working on that, and it sent a pipe, that pipe, through his skull. And that's the we have a approximation of how that actually worked, but that was the actual pipe that went through his head, and it went through his head, and he was completely coherent. The guy was able to talk. He was awake and aware. Now, of course, I mean, the guy had a pipe in his head, so it's not like he was giving fantastic responses and stuff, but he was able to respond. They were able to get him into the car, or into the car, into the carriage to get him home, completely coherent, talking the entire time, everything like that. Pulled the pipe out. They get him to the house. The doctor came and said, um, no, there's no way that a pipe went through this man's head because there's no way you could have that much brain damage and still survive. Now, of course, at this time, they did not have any we didn't really understand what parts of the brain did what did certain things. So they just said, "Hey, any damage to the brain, there's basically no way that somebody would be able to survive that." Then, a couple seconds later, Phineas sneezed, and a section of his brain, according to what was said, a section of his brain flew out of the top of his head and landed into the saucer of not saucer, the doctor's teacup, so big that it filled the teacup. That's what they specifically said had happened at that point. At that point, the doctor started believing it. Ramsey, please ask a question.
Oh no, I just wanted to say I heard about this story like a while ago. When I first heard about it, I didn't think it was real. I heard it was like I thought it was like a folk tale because it just sounded so unbelievable for this to happen. And I find it interesting that it's like it was actually a real thing. I mean, I'm
Oh,
not figuring that it was a real thing now, but I just been knowing that. I thought it was
yeah,
very interesting. I don't know, a hard time believing it.
yeah, totally.
And I also heard that he mostly lived a normal life.
Oh, totally.
He- like he had a little. I think he started being like an alcoholic. I'm not sure if that was true,
And that's
or
the next thing.
or if it even has to do with this. But apparently, he lived a relatively normal life.
Oh, and that's the next point that I'm kind of getting into. So, great. So, yes, this happened. The man was able to survive it. That in itself is cool. But what do you think happened to his brain with the frontal cortex? So, his frontal cortex was what was damaged.
He was probably less likely to think about the decisions he was making, more impulsive.
Mm-hmm. He became very not judgmental. He became very irritable. Accounts at that time were that his personality almost completely changed. He still remembered everything that he had because the brain's very plastic, but some of his judgments changed. Like you said, he started becoming an alcoholic, things like that too. Now, we don't have any real accounts of what his behavior was like beforehand to compare afterwards to make this really scientific, but it is one of the best stories that actually opens up so much in science research that we're actually able to start talking about what type of things like this happen. So he did end up dying at the age of 36. He was having lots of seizures and things like that too, which I mean, of course, it makes complete sense when you think about it from that perspective too. But yes, this is a totally true story that really is our buddy Phineas. So yes, we have some d distinct different roles. Do you guys want to have any other comments about Phineas? Cool. I will just make another terrible pun just because I am a father. His last name is Gage. I am thoroughly sad that never in the literature that I read do I ever find the gauge of that pipe. Any laughter? Horrible? I know. I'm sorry. I'm also trying to give you guys a mnemonic on that too. From actually mentioning that too, because, well, what was the gauge of the pipe? Well, we should ask Phineas. Cool. Left and right brainness. Some people will argue I am left-brained, I am right-brained. It is a lot more pop science on that, but there are elements about how one type of brain does process one type of the brain processes more than the other. Um, Sperry did earn his Nobel Prize working on this too, saying the left hemisphere of the brain tends to be for more verbal processing, the other tends to be a lot more for spatial. But and I had mentioned this a little bit too about the split brain experimentation on this too, about how we take in information, goes into the back of the head, and how it processes through each different signs of that. So yeah, there's they do have different functions. We can see different perspectives of how the brain actually works with that. So again, another thing if you want to specifically go into some perspectives of how different perspectives of the split brain perspective affects different aspects of mental illness or social interactions. Again, another fantastically beautiful paper I would love to read. Um, so chimeric faces. So there are things about it too. If you notice that we do not have symmetrical faces. None of us are really symmetric. If you look at a symmetric face, it looks weird. It feels almost uncomfortable to see that. But there are things that you can do if you like look at there's a thing here too where there's Leonardo DiCaprio on one side and Brad Pitt on the other. Is that Brad Pitt? Looks like Brad Pitt. Sorry, it's hard to see it. Based off of that too, and you're looking straight at it, you will only see one of the two. It's really hard to see them side by side. So you can trick your brain. This is one of the reasons why those magic eye puzzles, those things that you look at it and it's kind of wavy and weird with rainbow colors. They were really big in the 90s. You look at them like, "Oh, look, a boat or the Starship Enterprise." That's some of the type of things we're seeing with the cross brain look. You're actually supposed to look at the image, kind of cross your eyes and get it to where you get it to the point where your brain is seeing both of those. It processes them as one image and you start seeing a three-dimensional image. So cool stuff. Ways we study the brain. We have things like the encephalogram. I would recommend trying to say that 50 times fast, but the EEG, these are used very frequently in research as well too. This is where we're putting electrodes on people's heads where we can start seeing how they respond to that. Now, we're not reading minds with this. We're reading how the mind reacts to certain things. So we're not reading that too. But they have put electrodes inside the actual parts of cats and other animals like rats and such to find out how they actually have mapped the visual cortex, so how they can actually physically see stuff. We're actually starting to get to the point with some of the encephalogram things inside the brain where we can say exactly what a cat and a dog sees. So we're not very far off from that to where we're actually going to be able to physically start showing what human beings are able to see and be able to make it to where the blind can see. So again, in 20 years, I'm guessing that these slides will be dramatically different. Please be part of that research if it's something that makes you excited, because you literally can be the one that could make somebody's sight come back. And I'm not saying that lightly. I truly believe that in one of my classes, I will have people that will cure cancer, cure blindness, and things like that too. It's one of the major reasons why I want to be a professor because I want to be part of that. I'm not going to be the one doing it, but dang it, I'm going to teach the person that does. We do things like CT scans, MRIs, and diffuse tensor imaging. So there's some different types of those. Specifically, you can get into them as well too. But we find things like tumors, different types of how blood and such are running into the area of the brain. We actually don't have any blood specifically going directly onto the brain. There's a brain blood barrier that occurs. Blood is actually toxic to the brain. We're looking at some imaging here as well too, and we are seeing, sorry, it's been a while since I've looked at this as well too, a healthy slice and a not so healthy slice. So can anybody see where we have some pathology? Oh, sorry, both of them are healthy. I apologize. But yes, they're one's a cleaner image than the other, and I guess we're showing how much we have grown and moved beyond this as well too. So we're actually starting to see a lot more of the strata. We're seeing um, the sulky as well as a lot more of the fissures, things along those lines. Big brain, small brain. So having a big brain does not mean that you're smarter. Now, it does, the size of your brain can actually impact, like our brain is bigger than that of a rat. That doesn't mean that um, we have different brain capability. Well, we have different brain capabilities, but we have different growths in our brain, meaning our brains grow differently. Like the amygdala is actually much bigger in rats than it is proportionally inside of ours, because for them, that's more important. It's more of just the concepts of survival. Uh, got here too. Functional brain imaging. This we've mentioned these a couple as well too. These are some of the bigger things that we're trying. And a lot of your professors at Brooklyn are doing this type of research. So if you're really interested in it, search your professors and start saying, who does this type of thing? Reach out to them, say, hey, show me something cool. I guarantee you that they will jump up and down if you come into the room and talk to them. If they don't, if they actually just they blow you off, message me and I will call them and I will ream them up and down because this is the coolest crap in the world. And we need to get more people excited about it. Seriously, if they don't get excited to show you their research, call me on it because I will call them directly. Yeah, it helps us understand specifically individual things. Smaller on this too. We've labored a lot on fMRIs. This is kind of what some of them look like. And we start seeing things like, so we have here on the lateral lobe of the brain. What are we expecting to see on something like this? What type of stimulus are they getting? Exactly. So they're hearing something right now. Oh, good for you. Oh, sorry, my heart's just smiling, which is probably not good because that's my heart shouldn't smile. Doesn't have those capabilities. Sorry. Transcranial magnetic stimulation. It temporarily deactivates neurons in the cerebral cortex. Um, and it can mimic brain damage. What does that sound like? Okay, since somebody's mentioning that's that's electroshock therapy. It's a version of that, and now we're starting to use that with fMRIs to start actually purposely damaging parts of the brain that are not working the way they're supposed to. And then because of the plasticity of the brain, it starts healing from the other side of the brain that actually is working, and it starts repairing the damaged section into what is the initial homeostasis and the factory default of the brain. Amazeballs, right? Holy crap. We got through it all. Any questions? So, well, I'm sorry. My camera's a little bit off on me. Was this useful? Did you guys like this? This is the lecture that I was, to be honest, the most nervous about giving. And the reason being is I love this so much, and I'm not giving it anywhere near enough justice. My wife, if she was standing over me, would probably be just like, but, and just want to add more into it. So, if she was not sick right now, I mean, like I'm taking her to her doctor in about an hour or so. Um, if if she was not sick, she was planning on being here because she's even more passionate about this stuff than I am. It's amazing things. We in our office will often treat people that are having balance issues or things along those lines. We will use things like red laser and work the cranial nerves while they're standing on a vibration platform that we are messing with their proprioception and telling the brain basically in that same way that we would do like a type of electroshock therapy, but we're using lasers to just say, hey, there's a problem here. Maybe you should fix this, fix your proprioception. And would you believe it kind of works? Like, kind of like we have a very high success rate with that. And of course, we'll have an MRI beforehand to say, hey, here's where we don't have anything massively pathological going on. So, yeah. Did I cover enough psychology with this, or did I just do only brain? It's hard not to talk about, you have to kind of start with the brain, but now the rest of all the lectures we'll have, we'll be able to to reach back to talking about the brain, just about saying, oh, well, but this is where that's occurring. That's where the problem actually kind of pathologically happened. So the reason why I'm also asking for feedback on that point too is I have two other classes I'm teaching on this as well too, and I want to get better at it. Freaking love this. Cool. For next week, read the next chapter. I'll post um another what it was called, a quiz. I'll get the first one up for you guys too. Happy Valentine's Day. Enjoy your VD. If you got the wrong one, make certain you get meds.
Thank you, Professor. Have a
Thank
great day. Happy
you.
Valentine's Day. Bye bye.
A bientôt. Bien bonjour.
Adios.
Vaya
Professor.
con Dios.
Hi, sorry, I have a question regarding the research.
Bring it.
Okay, so I noticed like in one of the buildings at college, so they were advertising about like how socioeconomic status kind of affects hearing. Is that like the type of research I would be fine to participate in?
Please participate in that. Oh my God,
Okay.
that sounds exciting.
I thought it was cool, so I was like,
No, 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 you should do stuff like that. That's exactly the type of thing that we're wanting.
uh-huh. Okay, so I guess I'll reach out to them.
Yep. You're
All
loved
right.
more than lobster and twice as kosher.
All right. Thank you so much.
Anybody else got any other questions? Cool. Getting to my kid. A
All
bientôt.
right.